Alright, so this is the solution to part 2 to problem number 4 in the review tutorial. If a monopolist cannot tell who is what type and can only charge a single per unit price for insurance, what will she do assuming there are gamma type 1 consumers and 1 minus gamma type 2 consumers with gamma less than 1 over 2? So let's turn directly to the solution. Okay. Now let us determine first, is this a kind of price discrimination? Well, from the information that is given to us, we can see that actually there is no price discrimination. Why? First of all, the monopolist cannot tell who is what type. Okay, that's not the necessary condition, because in price discrimination sometimes the second degree price discrimination, the monopolist cannot tell who is what type. But the second piece of information says that can only charge a single per unit price for insurance. So it means that one price to type 1 customers and type 2 customers, and also it charges per unit price for insurance, so it is not allowed even to charge a 2-part tariff, right? So a fixed fee. Okay, so in this case the monopolist will maximize the expected profit, right? So I write the expected profit in the following form. So I have gamma here for consumers, consumer 1, type 1 consumers. Okay, now PS, which stands for the single per unit price, minus, since our cost is, the marginal cost is constant, so it's going to be per unit cost. So PS minus 8 multiplied by the quantity demanded by type 1 customers, plus 1 minus gamma times PS minus 6. Now notice here that the type 2 customers, the providing insurance is less costly, so it costs only constant marginal cost 6, and then multiplied by quantity demanded by type 2 customers. Okay. Notice that I also replace the demands. Okay, so the type 1 and type 2 demands with the demands that are given, and replacing theta with 20, and here O. Okay, so my bad. This is supposed to be 10. Okay. Right. So this is my expected profit. Now, many of you may have a question. What is the meaning of the expected profit, right? So what does it really mean? Before explaining further, so let me give you an example of what expected profit is. So suppose you sell health insurance to 10 customers, 4 unhealthy and 6 healthy ones, right? So here you go, you have the 4 unhealthy customers and there are 6 unhealthy, altogether 10 of them. Although you charge the same price to each type of the customers, right? So it's given that you sell at the same price. So you sell different coverages which have different costs, right? This is our case. So your profit coverages, by the way, here mean that quantity demanded. So your profit is not the same from each type, right? Because their demands are different, the costs are different. So the profit from each type will be different, right? Here we have 4 out of 10 customers buying high cost insurance. And so this means that 40% of them, and 6 out of 10 buying low cost insurance, so 60% of the customers. Now, our your total profit will be, so calculating the profit of from one unhealthy individual, right? Since we have 4 of them, we'll multiply by 4, plus the profit of one healthy individual multiplied by 6, since we have 6 of them, and that is going to be our total profit pie. Now, what will happen if we divide both the left-hand side and the right-hand side of this function by the total number of customers, which is 10 in our case? So we will get the average profit per customer, right? So pi over 10 is equal to 4 over 10 times pi of the unhealthy plus 6 over 10 times the pi of the healthy one. Now, the expected profit that I was talking about is exactly this profit, right, that you will make on average on any customer. So just imagine you selling your health insurance, and you don't know who is who, so any customer that approaches you can be either a healthy or unhealthy one, right? But on average, how much money, how much profit are you going to make on any single customer? So that is going to be shown by the expected profit, so we denote it by E of pi, right? And so if I divide this, represented in decimals, I have 0.4 of the pi unhealthy plus 0.6 times pi of the healthy. Now notice that 0.4 and 0.6 represent exactly the proportion of the customers, right? 40% and 60% of the customers. So this is the expected profit. Now let's go back to the solution and see what we can do with this expected profit. So this is our expected profit, as we have found out, right, and just discussed. Now, see, if you look at this expected profit, we want to maximize it with respect to one single per unit price, PS, right, here. Now, since each type of the customers has his own demand, right, so willingness to pay, if I were allowed to charge different single per unit prices, then I would charge a price which would result from the intersection of the marginal revenue and the marginal cost curves, right? So for type 1 customers, it will be here, and for type 2 customers, this price is going to be right here, right? So, however, I'm not allowed to charge 2 prices, so I'm going to charge a single per unit price to both type 1 and type 2 customers. Now, what is this price going to be? Well, if you just think intuitively, right, the economic intuition tells us that this price must be somewhere between this price, right? So, and if you do the calculations, right, so this is going to be 8 here, okay, and this price, okay, so this price, if you do the calculations correctly, plugging in there, you'll find that this price is 14. So the profit maximizing price, PS, right here, is going to be somewhere in between 8 and 14. Okay, now what exactly it will be turns out will depend on the proportion gamma, right? So let's figure out how this will depend on gamma. Well, we know that to maximize any function, right, we need to verify, actually derive two conditions, right? So the first order condition is going to show as the optimal point, right? So we take the derivative with respect to PS from our expected profit function, right? So I trust that you just follow my derivations here, okay? You can double check them mathematically. So what I have is the following equation, right? So I set it equal to 0. So the solution to this equation, right, the solution to PS will denote the profit maximizing single per unit price that the monopolist will charge to both type 1 and type 2 consumers. Now, we must do one more thing. We actually need to check whether the sufficient second order condition holds, right? We're not going to do, we're just going to say that assuming that it does hold, and you can check that it does, really. We have the following, right? So we're just doing the algebraic manipulations with this equation. So first of all, we bring everything under one numerator, okay, and here as well, and then multiply everything by 20, so to get rid of the denominators. So since here the denominator is 10, I will have to multiply it by 2 right here, okay. Now I add the similar terms, so I have gamma multiplied by 28 minus 2 PS plus this part is still equal to 0. Okay, I open the brackets, then group the similar terms, okay, here. My point here, my objective is to find out PS, right? So I need to group the PS and then factor out PS. So I have all this expression that doesn't contain PS. And then my price, the profit maximizing price, is going to be this, right? So going to be this expression. Now look at this. The monopolist will charge this price, right? Which depends only on the proportion of type 1 consumers. This is a very interesting finding. Why? Remember that I just said, okay, in the previous slide, let's go back here, our profit maximizing price is going to be somewhere between 8 and 14, right? Why is that? Well, apparently, if there are more of type 1 customers, right, so I'm going to put a lot of weight on type 1 customers' profit, okay? And if my weight is bigger, so the greater is the weight for type 1 customers, this price is going to be closer to 14, right? And if gamma is very low, so it will be closer to 8. So that would mean that there are more of type 2 customers, and so I put more weight on type 2 customers' profit. Okay, and that's why there it depends on gamma, right? Of course, there are other numbers in there, so like 32 and 4. So these will be just constants, right? Derived from our problem and our condition. Okay, so that is our price, and that's the answer. That's the solution to part 2 of the problem. Now, let us see. So part 3 is a logical continuation of part 2. What would the monopoly price be if gamma were equal to 0? Okay, we just discussed it. What if gamma is equal to 2 over 7, right? So let's just use the formula, okay, the profit maximizing price. Now we're just going to plug in the value of gamma equal to 0, and this is going to be real simple. So the value is going to be, the price will be 32 over 4, okay, which is equal to 8. So basically that's what we were saying, right? We were saying that the price is going to be between 8 and 14, and we said that if gamma is equal to 0 would mean that there are no type 1 customers, right? Gamma equal to 0 means there are no type 1 customers. So the monopolist will simply focus on type 2 customers, right? And the profit maximizing price is going to be exactly at the intersection, at the quantity which results from the intersection of marginal revenue and marginal cost curve, right? Which is going to be exactly 8. Okay, so this makes perfect sense to us and confirms that our derivations were correct. Okay, so what would happen if the value of gamma would be 2 over 7? Okay, if gamma is equal to 2 over 7, then we plug in this value into the monopoly price right here. Okay, both in the numerator and denominator. So we get this number, which looks ugly, but actually, if you transform everything and write it like this, right? So you'll see that, oh, these things cancel, right? And then 216 is divisible by 24, so it's equal to 9, right? So the profit maximizing price is going to be 9, right? Now, we need to answer the question what the highest value of gamma can be, and which will still result in type 2 consumers buying insurance. So this is going to be determined by this equation. So where do we get this? Well, this is our profit maximizing price, right? But where do we get this 10? Well, we know that type 2 customers will buy only if the price does not exceed 10. In fact, if the price is equal to 10, so their quantity demanded is actually, their coverage, insurance coverage is 0%, right? They buy nothing. Okay, so upper boundary, right? So 10 is the maximum that the type 2 consumers are willing to pay. Okay, now if we rearrange this equation, right, because we're looking for the gamma, so we multiply both left hand side and the right hand side by the 4 minus 2 gamma, we get this equation. After some rearrangements, we get gamma equal to 8 over 16 or 0.5, right? Okay, so gamma equal to 0.5 actually is going to be the highest value of that will still result in type 2 consumers buying insurance. Actually, technically speaking, at this value, type 2 consumers will buy 0 quantity or 0 coverage of health insurance. So the highest value of gamma must be slightly less than 0.5. So in economics, we usually denote it by gamma minus epsilon, where epsilon is very small. It could be a very, very small number, so that gamma will be very close, approximately equal to 0.5. So that concludes our solution and the answer to part 3 of this problem.